Okay, we're looking at exponential and logarithmic rules here going on with our stuff. This should be a basic review, but when you have like bases and you're multiplying, you add the exponents together. So this becomes 3 to the 9th power, whatever that ends up being as your answer. For when you divide, then, instead of adding, you're going to subtract your exponents. So that would be 3 to the negative first power, which negative exponent, a lot of times they won't let you keep it as that. Negative exponent just means you flip the fraction, so 1 over 3 as your answer. When you do power to a power, you multiply, so that means your base is still 3, your exponent is now 20, 3 to the 20th power. These last two are probably the ones that are going to be a little bit new for some of you. When you have a fraction, you read it as power over root. So what that means is you have to the 4th power and the 5th root. So if they ask you to rewrite that, it would be 3 to the 4th power and then to the 5th root. So in this case, it would be the 5th root of whatever 3 to the 4th is, which is 81. Now, a lot of times, it'll be like this where you can't simplify it, or like number 5, you will be able to simplify. So in number 5, it means 8 to the 4th power and the 3rd root. Well, you could actually go the other way, the 3rd root and then the 4th power. Either way will work. Because I don't know what 8 to the 4th power is. It's a pretty large number. I would take the cubed root of it and I'd get an answer. I can go the other way, though, too. What is the cubed root, the 3rd root of 8? Well, that's 2. So you still have 2 to the 4th power in my lovely writing. 2 to the 4th power, which is just 16. That'd be the same if you went the other way, 8 to the 4th power, which is whatever 64 times 64 is. 8 to the 4th power is 4,096. When you take the cubed root of that, you would get 16. So it works either way, just obviously a lot easier to try to do it root first. Okay? Now, let's switch back and forth between logs and exponentials. You read this log base A of B is equal to C. You rewrite it by saying the base to the answer power is equal to the inside. So for example, if you get a log problem that reads like this, log base 4 of 64 equals 3, you need to read that as 4 to the 3rd power equals 64. That's just how you go back and forth between a log and an exponential. So basically, if you're solving these equations, it's almost like you're saying equals x. We don't know what x is in any of these, but we're going to try to solve them. So, to do that, you're going to just rewrite them each as an exponential. 4 to the I don't know power equals 16. Well, without too much difficulty, you should know then that x has to equal 2. For this one, 3 to the I don't know power equals 1 over 27. Well, the way you're going to read this is 3 to the what equals 27. 3 to the 3rd equals 27, but because the fraction was flipped, I need to make it the negative exponent, negative 3. For the 3rd one, log base E, well, it probably should have said ln instead of log base E, means the same thing, but you got to anticipate that E is your base to the what power equals 1. Anytime you have an exponential equaling 1, the exponent automatically has to equal 0 for your answer. That's a log rule that you just have to know. We'll go over a bunch of those log rules later. And this is another big one here of a log rule. You would make it 2173 to the what power equals 2173. Well, exponent has to be 1. If you're taking the base and the inside to be the exact same thing, that means that your exponent has to be 1. Log of 1 will always be an answer of 0.